All right, let's go ahead and look at the first problem. Tom invests $1,000. So that is your beginning amount into an account that earns 4% interest. Make sure you put that as a decimal. Compounded monthly, your N is 12. And it come out very well. He makes no other deposits with withdrawal. What will his account be in 10 years? So your time is 10. You just plug it into the formula. A sub naught parenthesis 1 plus R over N, all raised to the NT. And you get your answer. On number 2, the keyword is compounded continuously. As soon as you see compounded continuously, you need to think hurt. You plug it in, calculator work. Number 3, again, that one's very straightforward. The rate is 2% annually per year. If you hear squeaking in the background, that is Norm with his squeaky toy. He's carrying it around in his mouth. So going back to number 3, it's just a straightforward annual, no compounding. So just put it into your calculator, you get a little under 3 million, which all of these are reasonable answers. 4 and 5 are a little bit more involved. So Steve invests $1,500 into an account that earns 5% compounded quarterly. As soon as you see compounded quarterly, you know your N is 4. And if you hear what sounds like a dog fight, there are 2 puppies playing, so please ignore that. After how many years will his account reach 4,500? Well, that's your ending amount. So 4,500 equals 1,500. 1 plus 0.05 over 4 to the 4t. Use your compounding interest formula. I divided both sides by 1,500. That is where the 3 comes from. And I simplified what was in the parentheses. Rewrote it in log form. So log base 1.0125 of 3 equals 4t. Used my change of base. And then divided by 4. On number 5, invested 8,000. And there was a typo on that. That should have been 80,000. And she ended up with 80,000. So divide both sides by 80,000 and you get 10. To get rid of the exponent of 180, which was 12 times 15, I raised both sides to the 1 over 80. You could have taken the 180th root as well. Then I subtracted 1, multiplied by 12, and got 0.154. And again, I apologize if that sounds horrific. It really is just 2 puppies playing. The one who's making all the noise is Abby. She is 25 pounds of pure craziness. So 15.4%, that's a reasonable answer. Number 6, exponents and logs are inverses of each other. Number 7, you needed to expand that. So you've got 4 factors. 100, a cubed, y, and b, 7. The only thing I would do here is log 100. That's a common log. That could actually be simplified down to 2. Move the exponent out in front, and you get 3 log a, log y, plus 7 log b. And again, you're putting plus signs with all of those. On number 8, you needed to condense them. So I took that exponent and made, or the coefficient and made it an exponent for both of them. And then 47 or 49 to the 1/2 is like the square root of 49, which is 7. So that's going to be log base 4 squared over 7. I knew I was dividing because it was a minus sign. All right, and if you hear barking, that is 0 barking. Number 9, I set that equal to x. rewrote it in log form, 5 to the x, and 625 is 5 to the 5th, and got x equals 5. On number 10, again, I set that equal to x, and I thought of 36 as 6 squared. 36 is 6 squared, and then I wrote it as a rational exponent, so 2 over 3, and you get 2/3. Whenever you have a log with a base and an exponent of a base, it's like they cancel each other out. Number 11, the 10 to the 24 is 2 to the 8th. So then I wrote that as a rational exponent, 8 over 4. Okay. And again, I had the same log and the same base for an exponent. It just becomes 2. Number 12, I needed to use the change of base on that one. So you need a calculator for that. So the log of 25, get like 1.39. Divide that by the log of 1/3 is negative 0.47, and I'm going to get negative 2.9. All right, Zero's having his worst day ever because I'm not letting him outside. Number 13, you can see the work there. I rewrote 36 as 6 squared, 216 as 6 cubed. Took the exponents, set them equal to each other. 2x equals 3. X is 3 over 2. Number 14, you could just do that on a calculator, negative 3. Number 15, the natural log and the e are going to cancel each other out. If you don't believe that, set it equal to x. And remember, the base here is e. Rewrite it in exponential form. You're going to get e to the x equals e to the 5.8. Number 6 is no solution because you can't take a log of a negative. Number 17, I rewrote 11 as, or I'm sorry, 121 as 11 squared. Then I set the exponents equal to each other and got 8 over 5. Number 18, I wrote 27 as 3 to the 3rd. Rewrote 81 as 3 to the 4th. Set exponents equal to each other, got negative 9 over 8. 19, I subtracted 10 from both sides. That's where the 90 comes from. And then I divided by 10. And then I rewrote it in log form. The base here would have been 10. So 10 to the 300 equals 4x divided by 4. And it looks like I did everything but the calculator work on that. You're going to get something humongous. All right, on 20, what I did on 20 is I, oh, it's right there. I put the logs together because there's a plus sign. I can condense those, and that's 5 times 2a minus 9. Well, then I have a log set equal to a log. That means whatever the argument is has to be set equal to each other. And I got a equals 5. 21, I wrote it in natural log form. So the natural log of 4 equals 3x plus 3. Subtract 3, divide by 3, and you guys can do the calculator work on that one. 22, I'm not going to give you quite something this involved on a test for the study guide. I don't think I had worked it out ahead of time. I combined the factors on the left-hand side because there's a plus sign. That means I can multiply them and got 8x squared minus 16x plus 2x minus 4 equals 10 because I have a natural log equal to a natural log. And then I did factor out a GCF. However, it doesn't really factor, so I used the quadratic formula, which you can always solve any quadratic using the quadratic formula. All right. I went through that pretty quickly. I am available for questions today. And I apologize for the incredible noise in the background.